Hi, good evening, good afternoon, everybody. My name is Asaf Shahar. I'm from the product management team, and here with me is Netzer Shohet. He is the director of in R&D of Infinity Next. So you heard quite a bit in the keynote session about Infinity Next and that it's the next platform and architecture of Checkpoint. And in this session, what we are trying to do is provide you some insight of what it actually means. Not the big headlines, but actually what is Infinity 2, what its capabilities, an actual demonstration of different use cases. So we'll have a short intro about Infinity Next. It's a new policy model and three demonstration. One is how we provide web application security, IoT protection, and micro-segmentation. All that through the unique capabilities of Infinity. So why we have this Infinity and how we got this architecture and why we took this journey. It's an innovation that we are working on for the last almost 3 years. And when we started the journey, we looked at our customers and tried to understand what are the challenges that they have in their going forward in their ability to manage and operate the security of all of its aspects. And what we see is that there is a big transition in the market, in the IT space. Transition in a lot of vectors. It's not only one vectors. We have new technologies that gets adopted very rapidly. 3 or 4 years ago, nobody heard about Kubernetes and Dockers. Now they are everywhere. There's no organization that I know of that does not use these technologies to some extent. Very rapid adoption. Serverless. How many heard about serverless solutions or architecture development processes a few years ago? Now everybody knows this term at least. So we see very rapid adoption of new technologies, and we expect that this is going to be accelerated in the future. But it's not just that the development technology, also the IT processes are evolving. DevOps are much more dominant in the process of introducing new functionalities and handling a lot of things that the network guys did in the past. So we see new processes in our customers. And we understand that DevOps needs to be part of the security operation. We see the introduction of new devices, new endpoint that has compute. IoTs, for example. Much more people are on the move. So we see a lot of changes in the IT infrastructure that the traditional architecture and solution are not suffice or not optimal to provide a solution for. So we try to come up with a new concept of deploying and operating security that would answer all of these pain points or all of these hurdles that would support, as if you've been in the keynote of Gil, he mentioned that we want to support every environment, whether it's a cloud, data center, your network, any device, and all of that from a single platform with a very easy way both to operate and to manage the security. A few traits of Infinity Tech, we refer to that as a cloud-native security platform. And one of the key things is that we are adding new capabilities for enforcement or new enforcement points. So most of you are using, or all of you are using our gateways, which is a perimeter solution that provide all the functionality from the perimeter, a very big appliance that has a lot of functionalities within it. The concept of having a gateway as a perimeter and a way to provide security is very good when you are in a static environment like a data center, but in a dynamic environment, it's somewhat more problematic. The definition of perimeter is more problematic. You need much more control of your east-west traffic, of the things that are not under your control. Where is the perimeter when you are serverless? It's much harder to provide security if the only tool that you have is a perimeter gateway. So we introduced new enforcement capabilities, new enforcement point, and we thought outside the box. When I'm saying outside the box, it's outside the gateway. So we are introducing capabilities to distribute the enforcement point and to have it on the place that you need it by having a nano agent, which are small pieces of code that we can inject into the workload, whether it's a web server, whether it's a machine, whether it's Docker, or wrap serverless. So it's different ways to inject security services into the element that you want to protect or need the element that you want to protect, as well as IoT. But it's not just Nano Agent. In our current environment, there are a lot of tools to provide security. We call them native controls. The idea is that not everything needs to be enforced by an enforcement point, but you can use this native control to achieve your policies. So we are using also native control where we can. The management is provided as a service through our checkpoint portal, so you don't need to deploy a management server. All the agents are auto-updating itself, so there is no maintenance window for updates or upgrades. The security is always up to date. The platform will provide many security practices. It means that whether it's compliancy, whether it's threat prevention, whether it's web application control, all of that are different services provided over the platform. So it's not a point solution just for container security threat prevention. It's a concept, an architecture where we can provide many types of practices to many types of assets in many types of environments. All the solution, I mentioned that the process and DevOps are very prominent in the processes of introducing new functionalities, and the system is built that the security will be part of DevOps processes through full APIs and best methodologies how to incorporate the security into the DevOps pipelines. And as I mentioned, we aim to protect any asset anywhere, whether it's VM, container, serverless, endpoints, IoT, and so forth. So by that, I will...
Hi, everybody. So thank you. I'm Netzer. I'm the director in R&D, and I need my clicker. And that's also a part of my personality. I need clickers. And what I'm going to do now is even do a deeper dive into the actual essentials of Infinity Next. And everything that was discussed here will be shown as part of what I'm seeing right now. Let's first talk about the management model. There are two things about the management model that we need to do. You know what? Once before that, let's remind ourselves. This is a complex. This is we aim to give security to a complex environment, and all the things you see here are ways to mitigate that complexity. We're going to have always up-to-date security. All the components are automatically updated, so that reduces the complexity. And we want to do a lot of things that reduce that complexity in the management model as well. And the management model starts with two things. Basically, management for security should say, where do you want to secure and what security do you want to enforce. That's it. And we have those two things combined by rules. Rules say, where do I want to enforce security, and what security do I want to enforce? Let's start with where do I want to enforce security. I want to enforce security on the customer's assets. We're not talking about assets because there's no longer just the server that we once protected in the physical lab. And two things about assets that are important in Infinity Next in the way that we are seeing things. The first thing is the fact that you don't need to define your assets. Assets can be driven from the environment. We can detect assets by hooking up to inventories. We can hook up to AWS or any other public cloud vendor and get those assets. We can hook up to Kubernetes and get those assets. And we can hook up to AD server like we did in R80 and get those assets, those users. So we get assets dynamically from the environment. The second thing about assets that is important to understand is that we're not only getting the assets, we're getting their properties. We're detecting properties from what's written in the inventory. We're detecting properties by checkpoint code. We know that they run Windows or Linux. We know that they have a web server running or not, which web server. We can also get properties that are tags that are coming from the DevOps. DevOps today can tag with key value pairs almost any workload that is known. I can add the key value pair color red to an EC2, and I can add the label color red to a Kubernetes pod. It's called labels here, it's called tags there, but it's basically the same thing. It's key value pairs. And all those properties of assets are coming to our management. Why is that so important? Because now we can create a policy that is not based on assets, but it's based on the properties of assets. And that helps us so much to reduce the complexity because we're getting two main advantages over difficulties. We're getting a main advantages over the hybrid nature of the environment, which Asaf mentioned before, because properties can transcend environments. As I said before, I can put color red on an EC2, on a serverless, or on a Kubernetes pod, or in any other asset that there is. And that way I can create a robust policy which matches different environments behind the scenes, and I can have the same policy for them. It also helps us mitigate the dynamic nature of the environment, which also Asaf mentioned. If I have a pod in Kubernetes which goes up and down, up and down, up and down, I don't care. As long as it always goes up with the same properties, with the same tags as it's written on its pipeline, I will always provide it with the same security. The DevOps engineer that we spoke before can now work much more freely. I can create a contract between me as a security officer and him and say, if the workload is tagged like this, it will get the security that I want. And within that confines, he can operate in a dynamic fashion as he always wanted and in automatic fashion. Now, second thing is the practices. Practices is the security that I want to enforce. Now, what we wanted to do is create best practices. The object is called practices because it's aimed to be best practices. It's supposed to be a security configuration. It will be a security configuration that is very light, it's very easy to manage, and it has great defaults. It can be used out of the box. And once it's like that, it's a best practice that we can offer to the customer and allow him to create a very easy and simple policy despite all the complexity that we aim to handle here. And that's the great thing about Infinity Next. Now, let's see some real-life examples. We're going to drop into see three things that we are actually showing in three different tech room tables, which I urge you all to go and see much more of what I'm showing here. Each of the tables expands more. I also have a table, which is why my voice is a bit not as as it should be this hour. But I'm going to show you just a tidbit of every table. So protecting web application. Checkpoint's web solution is in EA level and is provided over Infinity Next. So it's a real-life solution for a complex environment which is protecting something that is most of the time the perimeter of the cloud. We have a web application hosted usually in the cloud, and it usually has an API gateway, and it can be reached from the internet. Now, we want to protect this. So how do we do that using the rules and the management model that we discussed before? We want to install an agent here on the API gateway, and it can create all sorts of security on the traffic that flows through this environment, and get server workload protection, web application, API protection, anti-web bots. And it does so with basically two separate practices that we have today: the web API protection and the web application protection. I kind of opened it up so you will be able to see what it provides. This is actually also shows you the configuration. Another thing to remember about WAP is that WAP is an evolution of WAF, and what WAF is known for is very complex and very strenuous configuration needs. And the WAP that Checkpoint offers today has none of that. It's very simple configuration. It comes out of the box like that. And let's see now how it looks like. Just a second. Okay. Okay, so let's assume I have a web application here, and look at this. This is a web application that we show in our example of some sort of power company which has a website where I can check out my power usage, and the same cloud also has a smart meter connecting to it. So it's an IoT device with a smart meter, and it's connecting to it, and it's reporting all sorts of power usage, and then everything goes up in the background. And in our environment, we can also do an attack. So I'm going to create a web attack string. And look at that. I'm going to open it here. I'm going to paste it. Oh, what happened? Second. Got on a Google ad by mistake. Okay. Okay, something happened. I don't know what, but let's go back. Oh, and look at that. My resource consumption is now 0, so I attacked the system. But look at this. Once, let's reset the environment. I'm going to reset the environment so I can show you how I am protected. And I'm going to go here, and I'm going to go to the rules. And here is the web application protection. And it was in transparent mode. This is why it didn't blocked it. So I'm going to move it here, and I'm going to enforce. Okay. And now what happens is basically this is the rules that I've shown you before. You see the assets that I'm protecting against. You see the practices, and basically that's it. You can always do some nuanced overrides on top of those best practices, but you can use best practices just out of the box. And in our case, let's see what happened now. So first of all, everything reset. Let's do this and go back here. Let's start reporting again. And here behind the scenes, we will see. Okay, and now let's try the attack again. Let's try it again. And it's blocked by Checkpoint. Okay, so it's just like with a click of a button, and we're blocking this as well. Let's see another scenario. Second, I'll move back to the slide. Okay. Let's go to an IoT device. It's an entirely different solution, entirely different environment, same solution. IoT device, this goes to the internet, and IoT devices are just really vulnerable. They can be so vulnerable. In the example I'm going to show you, it's not even an IoT device that is sold with a purpose. It's sold as a general purpose firmware where you install something on top of it. That's just like that's grounds for being vulnerable, because you don't know from the start what will happen there. And what I'm going to show you is a short film. Because IoT devices are much more harder to schlep around while you're where you're going from one presentation to the other. So on one side of the screen you see a device, and on the other side of the screen you're going to see just a second, let me see that it was played. It's not played. Play. Okay. Okay, so you have here a vulnerable device. Now what we have already installed on this device is an agent, and that agent also has a practice called virtual patching. Virtual patching is a way for me to download signatures to the device. It's not running. Okay, let's see why. Let me see. Okay. Just a second. I have a problem here. Thank you. Okay. Let's go back to our presentation. I'm going to be very careful with that from now on. So, okay. Okay. Okay, this was the IoT device, and I'm going to install an agent on the IoT device, as we're basically going to deploy on it two different practices. One practice is the IoT virtual patching, and the other practice is the workload protection, which is a more sophisticated way to protect. The IoT virtual patching is my way of sending out signatures to that device. So let's see if the movie works for me. I'm not sure why it doesn't work. Okay, so I'm going to do that manually. I'm just going to show it to you manually. Okay, so basically, I have an IoT device. As I said, it's like a general firmware, and we installed it in web server, and that web server implements a ping test. No, it's okay. It's okay. I got it. No, I got it. It's okay. So I'm going to show it like real quickly. It's even going to be faster than just playing the film. So what I'm going to do is I'm going to add a malicious signature that is a problem within the headers. And what will happen once I do that is that the command will fail. It failed because we already uploaded it with a signature. Now, I'm going to go to the Infinity portal, and I'm going to check out the events. And here you see the event was created. The CV is less clear here, but we basically created the log because we caught that signature. Now, virtual patching is easy. It's running the signatures, but we are doing something much more complex than that. We are able to harden the firmware today with injecting our own agent that does runtime sophisticated protections. And look at that. Right now we have an unhardened device. I created here a shell injection, and look at that, I was hacked. But now what I'm going to do is I'm going to run the hardened version of the firmware. I'm going to try it again. But this time it was blocked. There's no hacked here. And I get a log. Second. The log is going to be right. Shell injection. You see the log for shell injection. Okay? By the way, it took me a while to wait for the log because the video is an actual video of a real environment, which it took me some time to refresh until the log reached the environment, and I don't want to edit that part because it shows it's a real live environment. Okay, and one last thing. Look at that. What will happen now is I'm going to send out a long ping. Now we had max ping size protection for like ages ago. But let's say we didn't block large pings. This large ping specifically, what it does is it causes a buffer overrun. And what our sophisticated environment does is block it on the buffer overrun level. We actually detect in runtime that there was a buffer overrun, and we are protecting against it in a dynamic memory-based buffer overflow protection. So this is sophisticated IoT-specific technology that we are now employing in IoT devices. One last thing that I'm going to show you. Just a second. Once I move back to the PowerPoint slide. Okay. Microsegmentation in the cloud. So this is what Asaf mentioned before. Let's say I have in the cloud two different apps. I have an IoT app, I have a user app. I want to segment between those two applications. Even though it's cloud and it's so easy to accidentally make a connection between here and here if I don't define the access very well. And I'm going to do that using native controls because I can. In this case, what I'm going to do is show an example of those guys running in Kubernetes. In Kubernetes, you have a system called Calico that you can commonly install on top of Kubernetes and create access control. And this is what I'm going to show you right now. Okay, so I have very short time, so I'm going to try to make up for it very quickly. I'm going to do that without the microphone. Okay. Basically what I did is the following. Look at that. This is a much more complex environment. What I did was I created a property-based query on my assets, and I divided my assets to zones. And those zones are shown here in these squares. And why is that? And I also created adjacency between those zones. And what happened here is that now I have the best practice for access. My access can now enforce the access according to this diagram. And this diagram is already dynamic in nature, transcends environments, and transcends the dynamic nature of pods going up and down within each of those zones. And for my final act, I will just show you this. Let's see that it works for me. I'm going to connect to Kubernetes. See that I didn't lose any. Okay. Look at this. I can connect to Kubernetes. This is a Calico environment, and each of those lines represent rule set that we have created for each of the zones that you've seen before. And if I dive into one of those zones, I can see egress rules, outgoing rules. Basically, it's one of the components that can only now talk to the database. The database is outside of the Kubernetes, so it's defined by IP addresses. And it can only be approached through the API gateway of that specific application. And that the API gateway of that specific application is defined by a dynamic pair of key value pairs. So this is what allows our system to be very dynamic, to be appropriate for the next decade, and to adjust itself to whatever technology will come in our way. I urge you all to come to the tech rooms and hear more about it in my table, in the table of the WAP, in the table of the IoT, and hear more about everything that I've just told you. Thank you very much.